Welcome back, everyone, to another deep dive.
Yeah, it's great to be back.
So today we're going to be tackling something a little complex, a little bit challenging. We're going to be talking about generative adversarial networks, GANs for short,
Right.
and our source material is a research paper, so we know that all of you listeners out there are up for the challenge.
Definitely.
But don't worry, we're going to break it down. We'll make it fun and interesting.
Absolutely.
And by the time you're done listening, you'll be able to drop GANs into conversation and impress all your friends.
That's the goal. Make you a Jan expert.
So to get started, the core concept of GANs, it's actually surprisingly simple.
Yeah, it is.
It's like a competition between two AI models.
Exactly, yeah.
Yeah.
Think of it like cops and robbers, or a counterfeiter and a detective.
Mm-hmm.
You know, one AI model is trying to create something, let's say a realistic image,
Okay.
and the other model is trying to spot the fake.
Ah, okay. So like one's trying to pull a fast one and the other one's like the quality control,
Right.
make sure everything's legit.
Exactly, yeah. So as the counterfeiter gets better at making fakes, the detective has to improve their methods.
Right.
Right, so it's this constant back and forth, and it pushes both of these AIs to be more and more sophisticated.
Oh, that's interesting. Okay.
Yeah.
So the paper refers to these two players as the generator and the discriminator.
Okay,
Can you break down their roles a little bit more? Like, what does each one do?
of course. So the generator, we call it G.
Okay.
That's the creative one. It starts with random noise.
Mhm.
You can almost think of it as just like a jumbled mess of data.
Right.
And its job is to transform that noise into something that resembles real data, like an image or a piece of music or even text.
Okay. And then the discriminator is like the skeptic.
Right, exactly.
Like, hold on, is this real or is this just a clever imitation?
Precisely. So D, the discriminator, carefully analyzes both the real data and the fakes created by G, and its goal is to become a master detective, to be able to tell the difference between the genuine article and the counterfeit.
So how does this play out in practice? Like, how do these two AIs actually, like, learn and improve?
It's all thanks to this ingenious training process that involves a concept called a minimax game.
Okay.
And this is a fancy term from game theory, but the idea is really simple. So one player tries to minimize their losses, while the other tries to maximize their gains.
So in this case, the generator, G, is trying to minimize the discriminator's ability to detect its fakes.
Exactly.
Right? While the discriminator, D, is trying to maximize its ability to correctly classify the real and fake data.
Exactly. And it's this push and pull,
Yeah,
and
yeah.
just makes Jan so powerful.
It's like an AI arms race. They're constantly trying to, like, one-up each other.
Exactly. Yeah. You can think of it that way.
So how does this Minimax game actually work? Like, how do they learn from each other?
That's where backpropagation comes in.
Ah, okay. Backpropagation.
Yeah, you might be familiar with this if you've, dabbled in neural networks. Both G and D are typically neural networks, and backpropagation allows them to learn from their mistakes and adjust their parameters to get better.
So they're basically getting, like, feedback on how well they're doing, and they're using that feedback to fine-tune their strategy.
Precisely.
Okay, so it's a constant, like, they're locked in this dance.
Yeah.
Each one's pushing the other to be better. What's the end goal? What are we trying to achieve with this whole setup?
The ultimate goal of a Jan is for the generator to become so good at creating fakes that the discriminator can no longer tell the difference.
Oh, wow.
Right.
So we're trying to create an AI that can, like, perfectly mimic reality.
Yeah, pretty much.
That's ambitious.
It is, yeah.
But how do you measure that? How do you know if the generator's doing a good job?
That's one of the trickiest aspects of GANs.
Uh-huh.
So unlike some other machine learning models where we have clear metrics, evaluating GANs is a little more nuanced.
So it's not as simple as saying, like, okay, the generator got, 90% of the images correct.
No, not quite. It's more about looking at the quality and the diversity of the generated samples.
Oh, yeah.
How well they capture the statistical properties of the real data,
Okay.
and whether they can fool human observers.
So it's almost like a little bit of art as well as science.
Yeah, you could definitely say that.
But even with these, like, evaluation challenges, GANs have already achieved some pretty remarkable results. Like, they've been used to generate these stunningly realistic images, compose music, write text, even create 3D models.
Exactly, yeah.
That's pretty incredible.
Oh, yeah.
So, what are some of the advantages of GANs? Like, what makes them so special compared to other approaches?
Well, one of the key advantages is that they don't rely on complex Markov chains, which can be very computationally expensive.
Okay.
So this makes them more efficient, more scalable.
So they're like computationally leaner.
Exactly.
Yeah.
Okay.
What else?
Another advantage is that they can represent very sharp, even degenerate distributions.
Okay, hold on. I got to stop you there. What does that mean?
Okay, so this basically means that they can capture those fine-grained details and those subtle variations that other generative models might miss.
So they're really good at like capturing the nuances of the data, like the subtle things that make it look and feel real.
Exactly, yeah.
Yeah.
And this ability to capture those subtle details is what allows GANs to generate such realistic and high-quality outputs.
Okay.
Yeah.
But I mean, no technology is perfect. There's got to be some downsides,
Of
right?
course, there are always challenges.
Okay.
And one of the biggest ones is that GANs don't provide an explicit representation of the data distribution. And this makes it tricky to evaluate their performance objectively and can sometimes lead to unexpected or undesirable outputs.
So it's almost like we're kind of letting this AI loose in this creative playground, but we don't have like a clear map to guide it or to fully understand what it's
You
doing.
got a good analogy, yeah.
Okay. So, and this lack of a clear map, that can make it tricky to control what the GAN generates.
Yeah.
But despite these challenges, I mean, GANs have shown some pretty incredible promise
Yeah, absolutely.
and have already led some really groundbreaking applications.
For sure.
So before we jump into, all those exciting applications, I kind of want to dig a little deeper into some of these concepts. Like you mentioned that training GANs can be tricky because you got to carefully synchronize the generator and the discriminator. Can you elaborate on that a little bit?
Yeah, for sure. So imagine if the counterfeiters, got so good that the police just couldn't keep up.
Right.
Right. In GAN terms, this can lead to a problem called mode collapse.
Mode collapse. That sounds a little ominous.
It kind of is.
What happens?
So it's when the generator starts producing a very limited variety of outputs, even if they're not very good. So instead of exploring the full range of possibilities, it kind of gets stuck in a rut, and it just churns out the same kind of fakes over and over again.
So it's almost like it finds a shortcut.
Yeah.
Like it figures out how to fool the discriminator without really understanding the complexity of the real data.
Exactly. Yeah. And this can lead to outputs that lack diversity and don't accurately reflect, the richness and variety of the real world.
It's almost like an artist who can only paint one type of subject.
Yeah, that's a good way to put it.
Even though they could be creating all these masterpieces.
Right.
So, so researchers are, they're constantly working on techniques to avoid this mode collapse.
Yeah.
And to make sure that GANs reach their full creative potential.
Exactly.
But even with these challenges, I mean, the results are pretty remarkable.
Yeah, they really are.
So we talked about the basics, the advantages, some of the challenges.
Right.
I want to see what these things can actually do.
Yeah.
It's like the paper mentioned some really cool visual examples.
They do.
Can we check those out next?
Absolutely. Let's take a look.
Yeah. I'm ready to be wowed.
All right. So are you ready to see like the magic of GANs in action?
I am all eyes.
Am I right?
What kind of visual wonders have these AI artists been creating?
Well, the paper really focuses on images, so let's start there.
Okay.
So imagine being able to generate like high-resolution photos of, anything you can imagine,
Right.
like, product prototypes or architectural designs,
Okay.
even fantastical creatures.
Hold on. So you're saying like I could get a GAN to create a photorealistic image of like a unicorn wearing sunglasses,
Yeah.
sipping a margarita on a
Yeah.
beach.
It's not out of the realm of possibility. I mean, there's already generating images that are nearly indistinguishable from real photographs.
Wow.
And the technology is rapidly evolving.
Okay. That's pretty mind-blowing. But let's move beyond like just creating like cool images.
Right.
What about like practical applications?
Right,
You
yeah.
know? Like how are GANs being used in the real world?
Yeah. So let's take the fashion industry, for example.
Okay.
Imagine using GANs to create like virtual fashion models,
Okay.
right? So you can showcase new designs without needing these expensive photo shoots
Okay.
or generating personalized clothing designs based on an individual's measurements and style preferences.
So you're saying like
Yeah.
I could have like a virtual stylist, create a whole wardrobe tailored just for me.
Yeah.
No more trying on clothes in cramped fitting rooms.
Exactly. Sign me up.
Right.
And the applications go way beyond fashion,
Yeah.
I mean, in healthcare, GANs could be used to generate synthetic medical images to train AI diagnostic tools.
Wow.
Or to create personalized treatment plans based on a patient's anatomy.
So we're talking about like potentially revolutionizing fields like medicine and design. This is getting serious.
Yeah, it really is. And the potential doesn't stop there,
Yeah.
Think about the entertainment industry.
Okay.
So GANs could generate realistic characters and environments for video games and movies.
Right.
So you could create these immersive, visually stunning experiences.
So we could have video games with like vast procedurally generated worlds that feel truly unique.
Right, exactly.
Or movies with characters that look and move just like real actors.
Precisely. I mean, the possibilities are pretty much endless.
Yeah.
And remember that GANs are not limited to just images. You
Yeah.
know, they can also be used to generate music, text, even complex scientific simulations.
Right.
So imagine using a GAN to like compose an original symphony,
Right.
or to write a novel in the style of your favorite author.
Okay. Now you're really blowing my mind here.
Yeah.
But with all this power comes, great responsibility, right?
Sure.
Like, are there any concerns about how this technology might be misused?
Yeah, that's a great question. And as with any powerful technology, I think we need to be aware of the potential downsides.
Sure. So what are some of the things that we need to watch out for?
Well, because GANs are so good at creating realistic content, there's a risk that they couldn't be used to generate fake images or videos that are difficult to distinguish from real ones.
Ah, I see. So it's important to develop ways to detect these fakes.
Right.
And just ensure that GANs are used responsibly.
Absolutely.
So getting back to those visual examples that you mentioned earlier,
Okay.
can you tell me a little bit more about what you found like particularly interesting in the paper?
Yeah, absolutely. So Figures 2 and 3 in the paper are particularly fascinating.
Right.
Figure 2 shows a variety of images that were generated by GANs trained on different data sets.
Okay.
And you can really see how these GANs have learned to capture the essence of different types of images, from handwritten digits to realistic faces to complex scenes with multiple objects.
So it's not just about creating a single type of image. Like GANs can be adapted to generate all sorts of visual content.
Exactly, yeah. And what's even more impressive is that these generated images aren't just copies of the training data.
Right.
They're novel creations
Yeah.
that reflect the GAN's understanding of the underlying patterns and structures.
So that's what makes it so intriguing to me is that these AI models are exhibiting a kind of creativity.
Right.
They're generating something new based on what they've learned.
Precisely. And Figure 3 in the paper showcases another really fascinating aspect of GANs, something called latent space interpolation.
Latent space interpolation. That sounds pretty technical. Can you break it down for us non-experts?
Yeah, sure. So think of it this way. The generator takes random noise as input, right, and transforms it into an image. This random noise can be represented as a point in a multidimensional space, which we call the latent space.
Okay. So each point in this latent space corresponds to a potential image that the GAN could generate.
Right.
So what's interpolation all about?
So interpolation is about smoothly transitioning between different points in the latent space.
Okay.
So imagine you have 2 points representing 2 different images. If you gradually move from one point to the other, you're essentially morphing one image into another, and you're creating a kind of animation.
Ah, so it's like watching the GAN's creative process unfold.
Exactly.
We're seeing how it transitions from one concept to another.
Yeah.
Okay.
And this latent space interpolation technique has all sorts of interesting applications,
Sure.
from generating realistic animations to just exploring the creative possibilities of GANs.
Okay. This is all very interesting. It's making me wonder though about, some of the ethical implications.
Yeah.
Like, could GANs be used to create, say, digital clones of real people?
Yeah, that's a very important question, and it's one that researchers and ethicists are actively grappling with.
Yeah.
While the technology isn't quite there yet, it's certainly a possibility that we need to consider as GANs continue to evolve.
It's both fascinating and a bit unsettling to think about,
Yeah.
where this technology might lead.
Yeah, for sure.
But, as you said earlier, technology itself is neutral.
Right.
It's how we choose to use it
Exactly.
that matters.
Yeah, it's up to us to ensure that GANs are used responsibly and ethically.
Well said.
Yeah.
Um, Now, the paper also highlights some of the advantages of GANs compared uh, to other generative models.
Right.
I'm particularly interested in the fact that GANs don't require complex Markov chains.
Right.
Can you explain why that's such a big deal?
Yeah, sure. So Markov chains are a powerful tool for modeling sequences of events,
Okay.
but they can be very computationally expensive, especially when dealing with high-dimensional data like images. GANs, on the other hand, don't rely on Markov chains, which makes them much more efficient and scalable.
So that's why GANs are able to handle those, complex, high-resolution images so effectively.
Exactly, yeah. And this computational efficiency opens up all sorts of possibilities for using GANs in real-world applications where speed and scalability are critical.
Okay, that makes sense. Now, you also mentioned that GANs can represent very sharp, even degenerate distributions.
hmm
Can you unpack that for us? I have to admit that one went over my head a little bit.
Okay. It's a bit technical, but basically it means that GANs are really good at capturing those fine-grained details and subtle variations in the data.
Okay.
Other generative models might struggle with this, but GANs excel at it.
So they're able to generate outputs that are not just realistic, but also diverse and nuanced.
Precisely. And that's a key reason why GAN-generated images often look so convincing.
Yeah.
They're not just generic approximations. They capture the subtle details that make each image unique.
That's really impressive. But of
What-
course, no technology is without its limitations.
Right?
What are some of the challenges that researchers are still facing with GANs?
Yeah. Well, one of the biggest challenges is that GANs don't provide an explicit representation of the data distribution.
Okay.
And this makes it tricky to evaluate their performance objectively.
Wow.
And it can sometimes lead to unexpected or undesirable outputs.
So it's like we're giving the AI a lot of freedom to explore and create,
Yeah.
but we don't have a clear map to guide it or to fully understand what it's doing.
That's a great analogy. And this lack of a clear map can make it difficult to control what the GAN generates, which
Yeah.
is why researchers are constantly working on new techniques to improve the stability and the controllability of GANs.
Okay, that makes sense. So we've covered the basics, the advantages, the challenges.
Yeah.
What I'm really curious about is what the future holds for GANs. Like, where do you see this technology going in the next few years?
That's a great question. I think we're really just scratching the surface of what GANs can do.
Yeah.
As the technology continues to evolve, we can expect to see even more realistic and impressive outputs, as well as new and innovative applications in fields like art, design, medicine, and entertainment.
It's exciting to think about the possibilities.
Yeah, for sure.
But before we get too carried away with the future, I want to go back to the paper and explore some of the key insights in a little more detail.
Sounds good to me. Let's dive back into the research and see what else we can uncover.
Okay, so let's circle back to those visual examples from the paper. Figure 2, with that gallery of GAN-generated images, really caught my eye. What were some of the standouts for you?
I think what really struck me was the sheer range of what GANs can create. You see everything from simple handwritten numbers to lifelike faces to these really complex scenes.
So we're talking about way more than just making one kind of image. GANs are flexible enough to create all sorts of visual stuff.
Yeah, exactly. And the really wild part is these images aren't just copies from the training data. It's like the GAN is learning the rules, the patterns, and then creating something new based on that.
That's what I find so fascinating. It's like this AI is showing a spark of creativity, making something new from what it's learned.
It really is like a kind of AI artistry. Take those handwritten digits, for example. The GAN was trained on the MNIST dataset.
Right.
But if you look closely, it's not just copying and pasting from that data. It's learning how those digits are actually written.
So it's not just pulling from a library of existing digits. It's actually figuring out the rules and then using those rules to make new ones.
Exactly. And the same goes for the faces they made from the Toronto face database. They're crazy realistic with all these subtle details and expressions.
Yeah, I can see why some people get a little creeped out by this stuff, but it's also super interesting. The paper also talked about images made from the CFAR-10 dataset, right?
Right, and that one's got all sorts of different objects in it.
Mm-hmm.
And what's cool is they actually use two different approaches. Some images were made with a GAN using a simple, fully connected model, and others were made with a more advanced convolutional model.
Hold on, didn't we talk about those convolutional models before? With image recognition?
Yeah. Convolutional neural networks, or CNNs, are really good at dealing with images because they can pick up on features at different sizes and places within an image.
So by using a CNN in the GAN, it makes the generated images even more detailed and real looking.
You got it. The results are seriously impressive. The images from the CNN-based GAN are just dot next level when it comes to detail and how realistic they look. It shows how important that GAN architecture is for the final product.
Makes sense. So figure 2 showed us how varied and lifelike GAN-made images can be. What about figure 3? What stood out there?
Figure 3 is all about a really neat technique called latent space interpolation.
Oh, yeah, you mentioned that before, but I'm still not totally clear on it. Can you, walk me through it again?
Sure thing. So remember the GAN's generator? It takes in random noise and turns that noise into an image, right?
Uh-huh.
Well, that noise can be represented as a point in well, it's a multi-dimensional space, but we call it the latent space.
Okay, so each point in this latent space is like a potential image the GAN could make. So interpolation means moving between these points.
Exactly. It's like you've got 2 points representing 2 images, and if you slowly move from one point to the other, you're essentially blending one image into the other, kind of like making an animation.
Ah, that's so cool. So it's
But
like watching how the GAN imagines, how it goes from one idea to another.
that's a great way to think about it. And this whole technique has so much potential, from making realistic animations to just seeing what GANs can really dream up?
This whole deep dive has been amazing. I feel like I've learned so much about GANs, like from the basics to all the amazing things they can do.
It's been fun for me too. It's always cool to explore cutting-edge tech like this and see where it might go.
Totally agree. And it seems clear that GANs are going to change our world in a big way. We're not just talking about cool images or making music. This tech can change whole industries, push the limits of creativity, even make us rethink what intelligence really means.
Absolutely. And as with any powerful tool, we got to use it responsibly. The future of GANs is up to us.
Couldn't have said it better myself. So to everyone listening, here's a thought for you. Imagine a world where GANs are everywhere. What does that look like? Dream big, be thoughtful, and let's build that AI future together. Until next time on The Deep Dive, keep those minds curious.